All right, this is our 6.4 lesson on percents of increase and decrease. In today's lesson, we're going to be finding the percents of change in quantities. And to do that, we're going to be able to explain what it means to have a percent of change. We can find the percent of increase or decrease in a quantity. And then finally, we will look at something called percent error, how much something is off of the original. The percent of change is a percent that the quantity changes from the original amount. Now, we've worked with change a whole bunch in our lives, but what we're going to get into is showing the significance of a change of something. Okay? And to do that, I want to use an example of $5. Okay? In some times, $5 can be a lot, right? Let's say a 4-year-old has $10, but they lose 5. Well, that loss of $5 means they've lost half of their money, which is quite a big, significant chunk of it. But to a billion-dollar company, right, something like this, take away $5, they're still sitting pretty fine with, quite a bit of money. What our goal is to do is, instead of representing by how much change has happened, we want to show the significance of it through something called percent of change. So from my original amount, how much did it change? Okay. To do that, we need to do the following. We first need to find the amount that changed, and then we're going to divide it by what I started with. This is going to result in a decimal, which I'll change into a percent. Now we're going to have two different circumstances. There's going to be cases where I'm going to gain or increase, and there's going to be circumstances where I lose or decrease. When I increase, I need to take my new amount and subtract my original amount, showing how much I went up. Then I will divide by my original amount from where I started. In a decrease scenario, we just flip the top two around. We start with our bigger value, which was where I started with, and I subtract where I ended up down at. So, for an example, it shows this. It says the table shows the number of hours you spent online last weekend. What's the percent of change in your time spent online from Saturday to Sunday? All right. So when we label this out, right, we need something called our original amount and our new amount. Okay? Our original amount always refers to what came first. In terms of our weekend, Saturday was the first day. So our original amount is Saturday, and on Saturday, we spent 2 hours online. Our new amount would be whatever our total was on Sunday, since that came afterwards, and that was 4.5. Okay? Since this is a scenario where I start at 2 and I go up to 4.5, I've got an increase situation because my number of hours increased. Meaning, to find my percent change, I need to do the following. We're going to take our new amount, since it is greater, and we're going to subtract away our original amount. Once we know that, we will divide all of this by where I started at, which is my original, to get a decimal, and then we'll change that to a percent. So, in our case, it looks something like this. Our new amount, or where we got up to, was 4.5. We're going to take away where I started with, which was 2. After I do that, I'm going to divide all of this by my original, which was Saturday, or 2 hours online. Up top, 4.5 minus 2, we're going to subtract that first. I've got 2.5 over 2. And then finally, 2.5 divided by 2 gives us 1.25. Now again, this isn't my percent yet. This is the decimal form of it. Meaning, to change this to a percent, I either can multiply this number by 100 or simply move my decimal 2 spots right. Meaning my percent of change in this scenario is 125%. Now, to finish this off, I do need to say whether I went up or down. And the way we're going to do that is we're going to look, when I started at 2, did I go up or down to my new amount? Well, in this case, 4.5 is bigger than 2, so we would say that this is an increase. Another example here, sometimes I don't have all this information, and I'm just presented with 2 numbers. In the case of this, we can assume that I started with the first one, so we would label 27 as my original, and 32 then becomes our new amount. Just like before, our percent change can be done by taking our new amount, which is 32, subtracting away our original amount, which is 27, and then dividing this entire thing by 27, since that's where I started. We always put where I started on the bottom. 32 minus 27 is 5. 5 divided by 27 will give us a decimal that looks something like this. 185, 185, 185, and so on and so on. For the purposes of our class, we really only need like the first 3 or 4. I'm just going to keep 4. We're going to move our decimal twice to the right to change this into a percent. And we would get around 18.51%. Since I started at 27 and I went up to 32, this would be an increase. All right, here's a couple try it problems for you to try out. All right, we're looking for our percent of change. Remember to label or change it into a percent at the end and to label increase or decrease. For number 1, 10 inches is my original, since that's where I start at. 25 becomes my new amount. My percent change can be found by taking my new amount, 25, taking away our original amount of 10, and then dividing this whole thing by my original, which is 10. 25 minus 10 is 15. And we're going to divide 15 by 10. I get 1.5. Changing this into a percent, I move 1 and twice, but I'm missing a spot, so I'm going to fill in with a 0, giving us 150%. I started at 10 and went to 25, so this would be an increase. For number 2, 57 becomes my original. 65 becomes my new value. My percent change can be done by taking my new value, subtracting my original, and then we would divide by the original. 65 minus 57 is 8 over 57. When I do 8 divided by 57, I end up with a long decimal. I'm going to take the first 4, which are 1403. I'll move my decimal twice to the right, and we end up with 14.03%. Now it does say round to the nearest tenth, so I'm going to round to this value here. My neighbor next door is a 3. That's not going to cause it to go any higher. So rounding this, we would just say 14.0%. And then I have to look, I started at 57 and went to 65. So that means I increased. All right, so that was percent increase. Now we're going to look at percent decrease, so a situation where things go down. Okay, what it says is that our bar graph shows a player's home run totals. What is the percent change from 2016 to 2017? So notice we're not looking at the years themselves, but rather in the seasons of 2016 and 2017, we're looking at the home run totals that were hit. So in this case, 28 and 20. Just like before, I need to label my original and my new. My original is always the one that comes first. In terms of years, it's the oldest year. So 2016, we're going to label as the original. 2017, we're going to label as the new. And then from there, the only part that switches is that instead of taking my new amount minus my original, for decreases, we take our original minus our new. What you should notice is that whenever you are doing the subtraction right away, your greatest value should come first, meaning your answer is always positive. Right? If I did my new minus original in this case, I'm actually going to get a negative number and get a negative percent, which we usually don't work with when we talk about percent of change. Okay? So again, 28 becomes my original since it pairs up with 2016. 20 becomes my new amount since it pairs up with 2017. And we can go through and do the following. My greatest value, or in this case my original, is 28. We'll subtract away 20 since that's my new amount. And my original amount in this time is 28. Notice if you remember last time, it was kind of our second number that we chose. In this case, it's going to be our first since that's my original in this case. 28 minus 20 is 8. And again, we're going to divide this by 28. When I divide this by 28, I'm going to do a little bit of rounding. We get 28, or 2857 after our decimal place. This one doesn't say for us to round, so I'm just going to move it twice. And we would end up at 28.57%. This time, since I started at 28 and I went down to 20, we would say that this is a decrease. From my original, I had to go down to get to my new amount. Another example for you here. Find the percent of change from 20 days down to 12. Again, I started at 20. That's my first one I see, so that's my original amount. Down to 12 would be our new amount. And again, for percent change, we are going to take our greatest value, which is 20, subtract our smaller value, which is 12, and we always divide by the original. 20 minus 12 is 8. 8 divided by 20 gives us 0.4. To change that into a percent, we move it twice. I have to fill in my extra slot with a 0. So we would say that this is a 40%. To go from 20 to 12, I go down, meaning it is a 40% decrease. All right, here's your try problem. It actually goes right along with the problem up on top, which is the bar graph example, except this time I'm looking at the years 2014 to 2015. Go ahead and try that out. Okay. In 2014, 18 home runs were hit. That is my first year, so this would be my original amount. 2015 is my new amount, since that comes next, or it's the latest value that I have. That'd be 10. And so to find the percent change, we would need to do 18, since it's my bigger number, subtracted by 10, since it's the smallest. And I always divide by my original. My original in this case is 18. 18 minus 10 is 8 over 18, which when I divide this out will give me 0.4444, a whole bunch of them on and forever. I'm going to change this into a percent, and I get 44.4 repeating percent. If you just choose the first 4, if you get 44.44, that's totally fine. Since I started at 18 and I had to go down to get to my new value of 10, this would be a decrease. All right. Last kind of new concept is going to be something called percent error. Percent of change and percent error go really well together. They basically have the same setup. Instead of this time, we have a little bit of a different way. Instead of saying original and new, we kind of replace it with something else. Okay? The percent of error just means how much does it differ from what's expected. Okay, we see this a lot in companies when they are testing different things, right? When they fill a bag up, they're expecting it to be some sort of amount. It's not always that amount, but as long as they're within a certain percent of error, they're okay to go ahead and ship that off to like stores and stuff. So the way we're going to find this is we're going to find the amount of error, just like we found the amount of change. So there's going to be some sort of subtraction. And then we're going to divide by the actual amount that we needed. Okay? So here we go. Our example 3 will kind of help us out here. In example 3, it says that our goal is to fill bags with about 16 ounces of homemade dog treats. The acceptable percent error when filling a bag is 5%, and we have to tell whether each bag is acceptable. Okay? So for doing our percent error, it's a very similar setup to what we just did with percent of change, except this time we need to kind of change our numbers up a little bit. Okay? Our amount of error is kind of found by doing the same thing, right? For doing percent change, we did the biggest number minus the smallest number. Sometimes it was my original amount, sometimes it was my new amount. Same exact thing happens here. The only difference is that we always are going to divide by the actual amount. And we're going to talk about what does actual amount mean. Okay? So, what I think of the actual amount, I think about it like this. If I had done it correctly, what should be there? Okay? So in this scenario, right, with my 2 different bags of dog treats, if I had done this correctly, I would have ended up with 16 ounces in each of these bags. Okay? So we can think of the actual amount as being what should the answer / amount be? So how much should I have? In this case, I should have 16. Okay, so in this example, our 16 ounces is the actual amount. That's what my goal was. Okay, my guess, or how much what ended up in the bag. In bag A, we see that 15 ounces is like what I did or what I guessed. So we're going to say this is kind of like our guess when we just randomly poured, hoping it would be 16. Okay? So for bag A, if I wanted to find my percent error, I would take my biggest number. So out of 16 and 15, 16 is the greatest value. I'm going to take away the 15 that was my guess and what I put in there. And I'm going to divide it by the number that if I had done this right, that's where I would have gotten to. In this case, it's 16. 16 minus 15 is 1. 1 divided by 16 gives us a decimal of 0.0625. Just like before, we're going to change this into a percent by moving our decimal over to the right twice. And I get 6.25%. And instead of an increase or a decrease, we really just have to say error. That's how much error there was. So again, my actual amount is if I had done this correctly, what should I have ended up at? My guess is like, what did I do? Like when I poured it in this case, I put 15 ounces in bag A. If I had done it right, I would have gotten 16. The last thing it's going to ask us is the acceptable percent error when filling a bag is 5%. Now, when we think about this, if this bag is acceptable, we would want that to be 5% or less, right? We don't want a lot of error. So when I compare these two, and I see that 6.25 is greater than 5, this is going to tell me that bag A is not acceptable. And the reason for it is it goes outside of the 5% of error that that's allowed. For bag B, we can kind of look at it the same. Again, my guess of 16 ounces, right? I actually put in 16.5. The actual amount that I was hoping for was 16 again in this case. This time, how much I put in is my bigger value, so I'm going to use that first and subtract by 16. We always divide by what should the answer be. So the answer should have been 16, or the amount that should have went in is 16. 16.5 minus 16 is 0.5. And 0.5 divided by 16 gives us a decimal of 0.03125. Moving my decimal over twice to make this a percent, I end up at 3.125%. And again, this is just 3.125% error. And I need to look at, is this in the acceptable range? This time, 3.125 is less than 5. So because it is 5% or smaller, we would say that bag B has an acceptable amount of error. It's within 5%. All right, for your try it, there's a couple things going on. First of all, what I would do first is I would identify what was my guess for about the number of bones in my body. And then for the actual amount, remember that's what the answer should have been. It's somewhere in here. Essentially, it's our correct answer. Find your percent of error first, then go back through kind of in that middle part to determine how many points you would have earned for this question. All right. So in this game, I'm asked how many bones are in the human body. My guess is right here, and we guessed 195. My actual amount is what should be the answer. The answer should be 206, and we see it here. The correct answer is there. So 206 is the actual amount. For my percent error, I need to take my biggest number, so 206, minus my smallest number, 195. And we always are going to divide this by the actual amount. So the actual correct answer is 206. 206 minus 195 is 11. And then when I divide 11 by 206, we end up with a decimal of 0.0533. Those are my first 4 digits after my decimal place. Changing this into a percent, moving over twice to the right, we get a percent error of 5.33%. And then what I need to do is I need to figure out, based upon the criteria above, how many points did I earn? Well, if my answer is at most 5%, so 5% or smaller, I would have earned 2 points. If my percent error is at most 10, so 10 or lower, I would get 1. Okay, and it's either 2 or 1. I'm either 5 or below, or I'm somewhere in between 5 and 10. Well, in the case of just 5%, right, both of these have a 5% or 5 in the ones place. However, 5.33 has kind of that extra thing. So we would say that that's a little bit more than 5%, meaning we don't hit our 2-point threshold. However, compared to 10%, 10% is clearly greater than 5.33. Because we fall in between 10% and 5%, we would earn 1 point. 1 point is our answer. Right, that concludes our lesson on percent of change and percent error. Remember that our biggest thing we need to know is how much did something change by. We then divide it by either our actual or our original to figure out, okay, contextually, how much did this actually change in percent form? And then again, for percent of change, we would say either say increase or decrease. For percent error, we would just write that's my percent of error.